Good morning, good afternoon. Today we're going to be talking in 3.7, Solving Systems of Equations by Graphing. Please follow along and fill out your notes. First part is filling out what a system of equations is. We've talked about this, but just a quick review. So a system of equations is two or more linear equations with the same variables. A solution of a linear system is an ordered pair that is a solution to all the equations in the system. On a graph, it's the points where the lines intersect. There are three types of possible solutions. Just intersecting lines, they're going to have one solution. If they are parallel, they will never intersect, so therefore there's no solution. And if it graphs to be the same line, there are infinitely many solutions. Alright, step one, graph each equation. You might need to rewrite an equation so it can easily be graphed. Identify the spot where they intersect and write the answer as an ordered pair. So we are going to do some examples from your notes. So solving the system y equals negative 2x minus 3 and y equals 2x plus 5 by graphing, you first need to start with that y-intercept. So I'm going to put a point at negative 3, and then I'm going to use the slope of negative 2 over 1. And remember, the negative 2 means I go down 2, 1, 2, and then I go to the right 1. So down 2 to the right 1. I can use those two lines. Those 2 points to create my line, or I can continue going down 2 over 1. I like to do this just because I need an exact point, and I like to make sure that I have the exact points correct. 2, 1. So those are going to be all my points on my line. And so I will go from the first one to the last one and create my line. Now I need to graph this one, y equals 2x plus 5, so I need to start at positive 5, and now my graph, or my slope is 2 over 1. Remember, if it's positive, you go up and to the right, so go up 2 over 1. Well, I'm off my graph, so now I could also go down 2 to the left 1, so down 2 to the left, down 2 to the left. Do you see how I went over that point? That's going to be my solution. So I can graph this line, draw my line, and this is my ordered pair that is the solution. So negative 2, 1, I need to write as an ordered pair. Negative 2, 1. So I believe we go this way. Now these are still pretty easy where we don't have to convert any of them. So y equals 4x. Remember, if I don't have plus or minus, if I add 0, does it change anything? No. So I know that that plus 0, that's my y-intercept. I also can tell that this is y equals 4x where I don't have anything plus or minus. So that means it's direct variation, and I start at the origin. The 4 is going to be my 4 over 1, or my slope, and I go up 4 and to the right 1. So 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Now that's off my graph. I don't need to actually plot that point. Down 4 to the left 1 would be the same. Down 4 to the left 1. Again, I go off my graph. So one of those 3 points should be where they intersect. Now I'm going to do y equals x plus 3. Again, I start at plus 3, so I go up to 3 and I put a dot. Then I need to go, because I don't have a coefficient, I know my coefficient is 1. That means my slope is 1 over 1. Up 1 over 1. And there I see my point. I do want to graph both my lines. And I need to write my solution as an ordered pair. Over 1 and up to 4. So 1, 4, done. If I wanted to check it, I can put both of these, this in for x and this for y, for both of my equations, and it should come out true. Okay, so this one, okay, if we have y equals 2, I don't have anything else. Remember, if it's just y, you have to go to the y axis and go to 2. This is where x or y is equal to 2. This is y is equal to 2. This is going to be a horizontal line across at y is equal to 2. So I'm just going to draw a line all the way across at y is equal to 2. Then I have to go here. If I look, this is not in y or slope-intercept form, so I want to get it into slope-intercept form. That means I want to get y by itself. So how do I get rid of negative x? I have to add x to both sides. So it's this will cancel out and go away. I have y left equals this x I want to write first, and then I have to write the negative 2. So here I look and I see that my y-intercept is negative 2, and then my slope is 1 again, so I go up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. Okay? Draw my line, and this point right here is where they intersect. This point is 4 and up to 2. Alright. Next one. Here I have 1 is my intercept, so I'll go put a point at 1. My slope is 2, which is 2 over 1. That means I go up 1 to the right 1. Up 2 to the right 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. I can also go down 2 to the left 1. Down 2 to the left 1. Down 2 to the left. Okay. Then I need to graph this one. This one again is not in y-intercept form. But I have to get y by itself, slope-intercept form. So I want to add 3 to both sides. That cancels that out. I get y by itself. Remember, the 3 can't be added to the 2x because they're not like terms. 2x, and then I have a negative 2 plus 3, so I'm going to be left with positive 1. Now it's in slope-intercept form. I have a point at 1, and then I go up 2 over 1, up 2 over 1, up 2 over 1. Now if you look, this is the same line, so I have only one line, so it's going to be infinitely many solutions. All of the points on this line are correct. Okay. Here again, I'm going to start with the easy one where it's in slope-intercept form. I'm going to go to positive 3 because of my plus 3, and then my 2 over 3 is my slope, so that means I go up 2 and to the right 3. Up 2 to the right 3. I could also go down 2 to the left 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Draw my line. Then I need to make sure to get this one in y-intercept form. So if I divide by 3, every term has to be divided by 3. 3 divided by 3 is 1, so I have y by itself. I have 2/3 x, and then 15 divided by 3 is 5. Now if I go up to 5, and I'm going to use my slope of up 2 over 3, or down 2 to the left 3. If I look, these lines are going to be parallel. Now sometimes when we graph, they're not very distinct. Maybe our lines are a little crooked. If you look here, these two equations, here and here, have the same slope but different y-intercepts. So that means there is going to never be a solution because they will be parallel lines. Same slope, different y-intercepts. The infinitely many one, we had same slope, same y-intercept. So it's the same line, infinitely many. Same slope, different y-intercept, parallel lines, no solution. Okay? Now, go to the right side. I think that is all we have. Alright, so our next inner notes are identifying the number of solutions without graphing. So if we have, again, I'm going over the same thing I just went over, but if same slope and different y-intercepts, there is going to be no solution because the lines are parallel. If it has the same slope and the same y-intercept, there is infinitely many solutions because the lines are going to be the same. If different slopes, there is one solution because the lines will have different rates of change. They will have to intersect at some point. Alright, a system of equations consists of two lines. One line passes through 2, 3, and 0, 5. The other line passes through 1, 1, and 0, negative 1. Determine if the system has no solution, one solution, or an infinite number of solutions. So you can look here and you can see you have 2 points. So from those 2 points you can figure out the slope. Remember the y minus the y, so 3 minus 5, and then 2 minus 0. So I have negative 2 over 2. If I look here, I have my slope is negative 1, and it is giving me the y-intercept. So negative 1 is my slope, y-intercept is 5. If I go over to this one, I'm going to have the slope is going to be 2. Different slopes, but right away, different slopes, it's going to be one solution. If it has the same slope, then you have to go and investigate further to see if there's y-intercepts are the same. But it's different slopes, so right away, no solution. I'm sorry, one solution. Okay. The next one, we have 0, 2, 1, 4, 0, negative 1, 1, 1. So at first glance, we see that the y-intercept is going to be different. So it's either going to be one solution or it's going to be no solution. So if the slopes are the same, it's going to be no solution because they were going to be parallel lines. So we're going to do 2 minus 4 on top, 0 minus 1. We get 2. Again, over here, our slope we get is 2, but our y-intercepts are different, so it's going to be no solution. Same slope, different y-intercept, no solution. But here we have 0, negative 4, 0, negative 4. This could be one solution where they meet at this point, 0, negative 4, or if they have the same slope, then it's going to be infinitely many solutions because it's going to be the same line. If we look, we have the same slope, the same y-intercept, so infinitely many solutions. Oops. Not much time left. Alright, so determine if each of the following system of equations has no solution, one solution, or infinite number of solutions. If there's no solution, find the solution. If there is a solution, find the solution. And I'm going to actually go back to my... Oh, this is not what I wanted to do. I want to go to my notes here. We did this and this. We want to go to Gregory Mooresburg has, and actually this is going to be part 1 because we're going to go into word problems, solving word problems, and that's going to take more than a minute, and I only have a minute left. So this is part 1 of 3.7.